Mm. Yes, I think we are live. Hello, everyone. Welcome again to another session of the IoT Space Challenge organized by the Tech Incubator of Deutsche Telekom together with hubraum. And today I have Frank with me, Frank from European Space Agency, and he will explain satellite IoT serving of Earth observation. But before that, I think now at that point everybody is used to, I would like to make a brief introduction on our program and give you some call to actions on how to apply. Yeah, let's move on. So IoT Space Challenge are organized by hubraum, the tech incubator of Deutsche Telekom, and we are looking for companies with the expertise in IoT and Earth observation, and ideally both. And companies are interested in bringing those two exciting fields together. So we encourage you to apply if you're interested in B2B collaboration opportunities within these two technical domains. And we are mostly looking for startups with a more mature level. So ideally, you should have your MVP tested in the real life setting. And what you are getting out of this program is, yeah, I mentioned also in our previous sessions, it is that there is a prize pool of up to 6,000 euros for to support creation of selected use cases. There is a support from Deutsche Telekom IoT with the connectivity and network expertise, together with an IoT prototyping platform. There is an access to Copernicus data space ecosystem and European Earth observation data access with European Space Agency expert support. You can access to hubraum campus spaces in Berlin and Krakow for working and prototyping, also with AWS credits. You get a potential co-investment by hubraum fund up to 1 million euros, and you get the opportunity to join larger ESA incubation programs. I will deep dive into what ESA is providing when it comes to satellite IoT in a moment, but let's move with the timeline. So we launched already our program and we are hosting the learning sessions, and we are more than halfway there. So this is our third session out of 4, and the application deadline is March 31st. So you're very strongly encouraged to apply for our program if you are working in one of those domains, IoT and Earth observation, and want to bring those two cool technologies together and work with an expert from European Space Agency and Deutsche Telekom sites. So this is our calendar. So at first we had a session on IoT, how to use cellular IoT and using IoT Creatives platform. And it's followed by a session on Earth observation and Copernicus data space ecosystem. And today's session is very exciting because this is the first session where we bring these two domains together. So at first, we deep dive in the technicalities of these two sessions, and today Frank will show us how to bring them together by satellite IoT. So he will show us the current satellite IoT solutions and how they can complement to your existing terrestrial IoT and Earth observation use cases. So we are very happy to have him here. And I would like to briefly mention that what you are getting out of this program when it comes to the satellite IoT side, that you are getting airtime via the satellite IoT companies. You have the chance to get various development kits for satellite IoT. You get the access to the platforms of the various satellite IoT providers, and of course, you get the European Space Agency IoT general expert support. And I believe Frank will give you more overview on what does this satellite IoT companies mean and how can you make the maximum out of it. But yeah, if these opportunities are any interesting for you, you're always strongly encouraged to apply. Here is the QR code. Here is a link. Here is a link also in the bottom. So you have all the ways to apply. And with that, I would like to hand the word over to Frank. And it's very nice having you here, Frank.
Thank you, Janset, for the introduction. Good. It is quite exciting here to present a few things, see the combinations of terrestrial IoT, Earth observation, and hopefully also a bit of satellite IoT components. Good. My name is Frank Zeppenfeldt. I work in the Satellite Communications Group of the European Space Agency in the Netherlands, and our day-to-day work is to support companies with new ideas in the area of satellite communications, and that includes also to bring into operation new concepts for satellite IoT. We'll explain a bit more what this is actually and how one could use it in this whole space IoT challenge. I was planning to basically use the following order. We'll explain a little bit what satellite IoT actually is and why would you use it at all. There are a few interesting synergies, we believe, between Earth observation and satellite IoT. We'd like to give a few examples. And then we go into what is currently a bit on the market in terms of satellite IoT solutions, in particular a bit the newer ones. And we come then a bit more to practicalities of using some of the satellite IoT solutions during the upcoming Space IoT Challenge. First, why use it at all? Now, what you see here is a map made during the night of the Earth, and you see here all the sources of light over the Earth. This indicates basically where people live in all the locations where there are light sources. But that is normally the place also where there's terrestrial connectivity. It's not always where things are. And we're talking here about the Internet of Things, agricultural sensors, moisture sensors, etc. That is very often happening in areas where there is no terrestrial connectivity. So there is possibly an opportunity to collect data via satellites because they either are high above the Earth or they circle the Earth. We'll explain a bit more about that later. The second reason is now back to this combination maybe of Earth observation and satellite IoT is that we see very often that satellite Earth observation takes place in areas which are very remote, where there is no terrestrial connectivity. So as such, we think the combination of terrestrial connectivity expanded with satellites and satellite Earth observation makes sense. To give further examples, where is now maybe possible synergies? If we take here a simple example where we have a number of projects that do observations, Earth observations in the Sahara, and they place several sensors there in the area, and data is collected from the sensors in the Sahara, and Earth observation is also made. So you have a good indication by means of Earth observation, and you have maybe even at the same time good data from your IoT sensors, which are very remote where there is no terrestrial connectivity. If we go to a second example, this is a slightly more technical, but you could imagine that an Earth observation satellite goes over a certain area, and at the same time, a satellite, an IoT observation is done, and as such, you have a perfect ground truth verification or validation of what you actually see with this Earth observation satellite. It serves very well the purpose of calibration of sensors, both on the ground and both on the satellite. We think that is very useful. Another possible synergy between the IoT satellites and the Earth satellites is the following, where, say, at a certain time, an observation is done, and suppose you do an observation of a certain value that should not exceed a certain threshold. Maybe the reaction to that could be that the Earth observation satellite comes over and takes maybe a specific type of observation. Maybe it's setting its sensors in a different way, or if it's a synthetic aperture radar, you put it in a different mode. As such, this is also an interesting combination or synergy between IoT satellites and Earth observation satellites. Furthermore, it can also be the other way around. Suppose the Earth observation satellite comes over at a certain time, but following what you see there with the picture from Earth, you calibrate or measure certain values in that area, and that can either be two ways. It could be that you want to measure something specific depending on the observation, or maybe you even actuate something. You could imagine that you, from the satellite, you actuate something on the ground, for example, closing a water pump or opening up a water valve. Those are interesting combinations one could do by this synergy of Earth observation and satellite IoT. These are mere examples. We hope you come further with good ideas in this whole space IoT challenge, which is all about combining IoT and Earth. Now let's go to a very high level overview of this satellite IoT so that you know what is on offer and we can later advise you on specifics. We would like to draw your attention that normally if we talk about satellite IoT, there are two solutions. One is what we call a bit more backhaul. There is actually, let's say, mobile IoT creators has a similar terrestrial option where, let's say, LoRaWAN gateway is backhauled via an LTE and modem. It's with the same principle, but in this case, the LoRa gateway or another type of technology is backhauled via satellite to the area where there is normal connectivity again, and you go into the backend. I'll show you a few examples of practical installations where people use this kind of solution. The other solution, which we would call direct access, is where the terrestrial or the sensors on the ground talk directly to the satellite. And a very nice thing is in some of the solutions that we'll show you, there is also the possibility to link these sensors to each other. So basically, you can make it like a meshed connectivity, relaying data between sensors, and then maybe one sensor sends it to the satellite. And the satellite that you see here, it could be a satellite which is so-called geostationary. So it is always hanging over the same place of Earth. This is very often similar like television satellites, where you see sometimes the satellite dishes pointed to one location. The other type of satellites is the so-called low Earth orbit or medium Earth orbit, where the satellite moves, and you normally have a lot of satellites such that every, let's say, 10 minutes or sometimes even continuously, you can offload your data via satellite. Now let's go to a few practical solutions. You recall I introduced this architecture or concept which is called backhaul. So you have a remote gateway or base station. We have here two providers, Minfarm and Crucial. We'll come later to the companies themselves. It's hardly visible here, but this is somewhere very far away in Scotland where there is a very remote LoRa gateway installed. And this LoRa gateway is backhauling all the data via satellite. So there is no terrestrial infrastructure possible at all. At the same time, here there is no Earth observation combination yet, but you could imagine that you deploy such a sensor in an area where you want to maybe locally deploy quite a number of sensors or actuators, maybe back to the water pump. And still this infrastructure, you can see from the solar panels, is self-supporting. So there's no need for power connections and so on. This is running completely on solar power, even on rainy days. So you could say this is a good solution if you are looking at maybe a larger geographic area, but not a worldwide coverage in this case. In that case, you would need to deploy more of those LoRa gateways that you see here. What is quite a nice advantage because you see a bit more infrastructure here. This solution also allows a bit of edge processing, if you can call it like that. A bit of intelligence at that site. You could send only the differences in sensor values, for example. You could maybe deploy tiny machine learning instances at that local edge. So there's all kind of interesting things one could do with such an infrastructure. And in terms of costs, you have to count on something like €1 to €3 per month per sensor for having a reasonable number of sensors. So this would be the cost you would have to get access to sensors which are deployed in such areas that you see on the picture. Let's go to the second one. That was the architecture which we called direct access. Now you see here example of 4 providers which would be very willing to support this space IoT challenge. Let us not go into the very specifics of every provider because it's a bit difficult to make a complete picture. That is best done when we are a bit further in the Space IoT challenge. But let's give a rough overview of what you can do with these solutions. Many of those solutions are now in orbit, so the satellites are traveling around the Earth, and all these suppliers have their development kits, which you could use to prototype and interface your sensors. And the message sizes that you can transmit via these satellites is often between 20 and 160 bytes. Satellites come over 2 or 4 times a day. Some people keep launching satellites, so that frequency is increasing. Some of those solutions are transmit only. That is also sometimes only required. And what is a very interesting thing that some of the providers which use standard protocols can easily switch also to terrestrial IoT and then maybe back to satellite IoT when they would not have coverage anymore. If you look at these development kits, if you would buy them new, I think we're looking something between 50 to 500 euro, and they will be an intermediate for you if you need access to the development kits, and expect in terms of costing something like the order of euros per month to euros per year per sensor. Now, you have seen that this satellite, in this case, is the version which is a low Earth orbit satellite or a medium Earth orbit. So they travel around the Earth and you see them, let's say, between 2, 4, or even more times a day. Another solution is that you have this satellite to which you send the data directly is a geostationary satellite. And that is a solution which is recently on the market, offered by EchoStar, and message sizes are around 50 bytes. It's covering the whole of Europe. This is also offering the handover between terrestrial and satellite LoRa, and there are various plans from 4 messages to 8 messages a day and even further. That depends, and we're again here at the costing plans of, let's say, euros per month per sensor. That's a bit the cost you should. If we go now back to the practical use of these systems during this Space IoT challenge. We hope, of course, that you submit your applications showing the integration of Earth observation and IoT, and there might be some satellite IoT needs there. You see there are many solutions with all their pros and cons. It's beyond, let's say, this webcast to go in details for every system. But you have seen there are systems that offer backhaul of LoRa or other type of gateways. You see here the companies Crucial and Minfarmtech. In the direct access, you see here the companies that use low Earth orbit and medium Earth orbit satellites, and the companies that offer geostationary satellites. We are interested to connect you to those companies. There needs to be a technical discussion, also one-to-one if you have very specific needs. The first questions we will answer on behalf of them. All these companies that you see here, they know about this Space IoT challenge, so you can also contact them directly. There's no need to go via us, but we are very happy to help. And all the companies there are aware of the Space IoT and can make available development kits and also airtime, costing, etc. Sometimes a bit on a case-by-case basis. That will need to be discussed really on a case-by-case. So far, I would say these are the solutions that are currently in the market, which are, let's say, a bit new. Coming back to maybe some ideas just for you to play with, that IoT sensors become smaller and smaller. And we think they could even go to wearables. You see here, there is an experiment we did with one of the companies listed where we have actually an antenna in a hat, and that hat receives directly information from the satellite or could transmit So you see here a combination of maybe remote people, satellite IoT, Earth observation. Who knows what kind of interesting ideas you could submit based on such combinations. The other thing maybe to consider is that some of the Earth observation satellites become actually very intelligent on board. There are full machine learning instances on board, inferencing machines, etc. And the IoT input, satellite IoT and terrestrial IoT, could be an additional input to those algorithms. We would also encourage you to take that into account. And finally, there are Earth observation is could be quite wide if you also include maybe ship detection, aircraft detection, radio frequency monitoring from space. You see here certain products. This is a map made by the company Orbcom of all the vessel positions received by satellite. This is radio frequency monitoring by the company Aurora. This is Spire company, which is monitoring aircraft positions. Now, there are plenty of such examples. You can see this is a bit the it's a between Earth observation and IoT, satellite IoT in, but we encourage you also to look at those kinds of sensors, which we think are we could provide added value to Earth observation. Finally, also on the satellite IoT systems, you will note we have not listed all systems. There are existing systems in the market, Iridium, Globostar, Inmarsat, etc. We have chosen not to list all of them. We know you can always contact the people, but it's a very dynamic area. We wanted to pick out a few systems of people that have stepped forward to support this space IoT challenge. So there are some very established players. We would also invite you to look at that market, and some very new players, which you have seen here. In general, be prepared for changes. This is a very dynamic world. There are people just offering services, people offering services for a few months. We need to be flexible also if you want to see certain services demonstrated. Then maybe back to the Space IoT Challenge. You've seen now a few systems. Maybe I'll go back still to the previous slide. These people know about the Space IoT Challenge. They would expect your call or your inquiries. And similar is that for the people that provide access to directly to sensors. We would encourage to look at the website of those companies or come to us for questions or clarifications. And we hope that you include some of those space or satellite IoT capabilities in this whole space IoT challenge. Then, Jan said, I think I go back to this slide, maybe for wrapping up by you or questions and answers.
Yes, Frank, thank you so much. So in the meantime, if anyone has any questions, feel free to ask them in the chat. And I would like to take this opportunity and ask you a question actually from my side. So could you please tell us a bit about like how does this additional satellite IoT benefits will improve let's say a terrestrial IoT company. So like let's say I have like a local based sensor solution, let it be a farming sensor or a parking sensor. How will I really like as the like a physical steps, how will I include this satellite IoT data into my existing solution, and how will it improve my solution? So could you like maybe give some more examples on that?
Yeah, that's maybe let's an example.
Sorry, you went on mute. Could you check that?
Yeah, one example Jan said is let's take the maritime business, containers on ships. There's various container tracking solutions. That is nothing new. But for example, an integrated solution that using the same standard, for example, narrowband IoT, as Deutsche Telekom IoT and IoT creators offer that. A sensor on a narrowband IoT node on a container could, for example, be seamlessly handed over to this satellite narrowband IoT connectivity when it's out of range of, let's say, land masses. The combination then, there are some people, in particular in the maritime insurance business, which are very interested to track what happened to a container when insurance claims are made. The combination with, for example, satellite observations with wave heights, storm warnings, etc., is interesting also as a, for example, a certain proof of uh, weather circumstances for insurance circumstances or insurance claims. Now, these are a practical example where you see the combination of terrestrial and satellite IoT plus Earth observation serving an actual purpose.
Yeah, it's really a no-brainer to see how they can bring together and improve the lives of especially the companies that are working more in this remote locations, the ships, the remote farming, the solar panels, and so on. Yeah, that makes it clear. Then maybe I would like to wrap it up here. So thank you so much for everyone that joined our session. We are glad to have you here on a Friday afternoon. It really means a lot to us. And I also forgot to mention in the beginning that the session is recorded. So if you'd like to go back and see what Frank just explained, it will be in hubraum's website from this in the same page of this application link. So you can just go to our IoT Space Challenge website and also see the recording of this session and our previous sessions. And yeah, if it is interesting for you to work together with the satellite IoT companies and get this expert support from European Space Agency, you are welcome to apply for our program. The deadline is in 14 days. So yeah, just I think it is coming closer and we are very looking forward to kick it up. And yeah, big thanks to you, Frank, for your presentation. Really appreciate that. So thanks for sharing your knowledge as well.
A pleasure. Look forward to your contributions for the Space IoT Challenge.
Always. Then we can end our session of today for now. And I am thanks everyone for joining. And I would be happy to see you in our next session. That will be at 21st of March, and the event will be created soon on hubraum's LinkedIn page. So stay tuned for that one as well. Have a great day, everyone. Thank you again, Frank.